Hi, I am Sayed on Maths Online. Today's topic is angle between the pairs of curves. In the previous video also we have done angle between the pairs of curves, but in today's session we'll try to show that the angle between the pairs of curves is 90 degree. That means the pairs of curves are orthogonal to each other. So let us take few examples. So the first question is show that the pairs of curves r is equals to a into 1 plus cos theta and r is equals to a into 1 minus cos theta intersect each other orthogonally. Let us take the first curve. R is equals to a into 1 plus cos of theta. So let me apply log on both the sides. So if I apply log, I will be getting log of r is equals to log of a into 1 plus cos of theta. So using the properties of logarithm, you will be getting log of a plus log of 1 plus cos theta. Let us try to differentiate this with respect to theta. So differentiate with respect to theta. So log of r differentiation will be 1 by r into dr by d theta. On the right hand side, log a is a constant, its derivative will be 0 plus log differentiation will be 1 by, it is 1 plus cos of theta, and differentiation of 1 plus cos theta will be minus sine of theta. This 1 by r dr by d theta can be written as cot of phi. So we know this formula, cot phi to be equals to 1 by r dr by d theta. So this will be equals to, here we have minus sine of theta divided by 1 plus cos of theta. So let us simplify this one. I can write this sine theta in terms of half angle formula as 2 sine theta by 2 into cos of theta by 2 whole divided by 1 plus cos theta can be written as 2 cos square theta by 2. We can cancel out this 2 and 2. 1 cos theta will cancel out from the numerator as well as from the denominator. So you'll be left out with minus of sine theta by 2 whole divided by cos of theta by 2. That will be equals to minus of sine by cos will be tan, so we'll be getting tan of theta by 2. So if you want to express this in the form of cot, so you can write cot of 90 plus theta by 2. So cot of 90 plus theta by 2 will be minus of tan of theta by 2. Now since it is the first curve, I will be taking this value to be equals to cot of phi 1. So therefore we have got cot of phi 1 to be equals to cot pi by 2 plus theta by 2. So this equality holds when the value of phi 1 is equals to pi by 2 plus theta by 2. So we have got the first angle phi 1. Let us move on to the second curve. R is equals to a into 1 minus cos of theta. Once again apply log, you will be getting log of r is equals to log of a into 1 minus cos of theta. So applying the properties of logarithm, we will be getting log of a plus log of 1 minus cos of theta. So let us try to differentiate this with respect to theta. So differentiate with respect to theta. Derivative of log of r will be 1 by r into dr by d theta is equals to differentiation of log a constant will be 0 plus differentiation of log will be 1 by 1 minus of cos of theta into Now differentiation of 1 is 0, minus sign as it is. Differentiation of cos theta will be minus of sine theta. 1 by r dr by d theta, we know it is cot of phi. Because it is the second curve, I will be taking phi 2. This will be equals to, so minus of minus will become plus. So we'll be having sine theta divided by denominator, you have 1 minus cos of theta, or this will be equals to sine theta, the half angle formula will be 2 sine theta by 2 into cos of theta by 2 whole divided by 1 minus cos theta, the half angle formula will be 2 sine square theta by 2. So you can cancel out this 2 and 2. 1 sine theta by 2 will cancel out in the numerator and denominator. You will be left out with cos of theta by 2 divided by sine of theta by 2. So this is nothing but cot of theta by 2. So therefore we have cot of phi 2 to be equals to cot of theta by 2. Therefore the value of phi 2 will be equals to theta by 2. So hence you got the value of phi 2 to be equals to theta by 2. So we know the formula, angle between two curves. So the angle between two curves is nothing but modulus of phi 1 minus phi 2. So this will be equals to, just plug in the value of phi 1. The value of phi 1 over here is pi by 2 plus theta by 2 minus of the value of phi 2 over here is theta by 2. So we just plug in, it is theta by 2. You can check that this plus theta by 2 and minus theta by 2 will cancel out. You will be left out with pi by 2. So whenever you get modulus of phi 1 minus phi 2 to be equals to pi by 2, we say that the two curves are orthogonal to each other, or the two curves are cutting at right angles to each other. So hence the two curves are orthogonal to each other. So that is the required solution. Let us move on to the next question. The next question is, show that the base of curves r power of n is equals to a power of n cos n theta and r power of n is equals to b power of n sin n theta intersect each other orthogonally. Let us consider the first curve. R power of n is equals to a power of n into cos n theta. So let us take log on both the sides. So we'll be getting log of r power of n. Log of r power of n is equals to, it is log of a power of n into cos of n theta. So using the properties of logarithm, we'll be getting n log of r is equals to, this will be log of a power of n plus, it is log of cos n theta. Or further I can write this as, this log a power of n can be written as n log of a plus, it is log of cos n theta. Now we'll try to differentiate this with respect to theta. So differentiate with respect to theta. So n as it is, derivative of log of r will be 1 by r into dr by d theta. That is equals to n log a differentiation will be 0 plus next term log differentiation will be 1 by, it is cos of n theta into differentiation of cos will be minus sine. So minus sine of n theta and differentiation of n theta will be n. So it is n times of, we have 1 by r dr by d theta is nothing but cot of phi. Because it is the first curve, I will be taking phi 1 is equals to, it is minus n into sine of n theta divided by cos of n theta. You see that this n and this n will cancel out, and we are left out with minus of sine by cos will be tan. So we'll be getting tan of n theta. Or this can be expressed in the form of cot. So I can write this as cot of 90 plus n theta. So 90 plus n theta will be minus tan n theta. Since on the left hand side we have cot of phi 1, therefore we get the value of phi 1 to be equals to pi by 2 plus n theta. So therefore the value of phi 1 will be equals to pi by 2 plus n theta. So let us try to evaluate the value of phi 2. So the second curve is r power of n is equals to b power of n sine of n theta. So here also we'll take log on both the sides. So we'll be getting log of r power of n is equals to log of b power of n into sine of n theta. So using the properties of logarithm, I can write n log of r is equals to, this will be log of b power of n plus log of sine n theta. Or further I can write log b power of n to be n log of b plus log of sine n theta. We'll try to differentiate this with respect to theta. So differentiate with respect to theta. So it is n as it is, derivative of log of r will be 1 by r into dr by d theta. That is equals to n log b is a constant, its derivative will be 0 plus log differentiation will be 1 by. So it is 1 by sine of n theta into differentiation of sine n theta will be cos n theta into differentiation of n theta will be n. So we get n cos n theta. So n into 1 by r dr by d theta is nothing but cot of phi. For the second curve, I will take it as phi 2. That is equals to n into, because it is cos by sine will be cot. So we'll be getting cot of n theta. You can see that this value of n and n will cancel out. So we are left out with cot of phi 2 is equals to cot of n theta. So this equality will hold good if the value of phi 2 is equals to n theta. Hence, the value of phi 2 is equals to n theta. Let's try to find out angle between the curves. So angle between the two curves will be nothing but modulus of phi 1 minus of phi 2. So that will be equals to modulus of phi 1 value that you have got is pi by 2 plus n theta. Then minus of phi 2 value that you have got is n theta. We see that the value of plus n theta and minus n theta will cancel out. We are left out with only pi by 2, 90 degree. So which means that the two curves are orthogonal to each other. Hence, the two curves are orthogonal to each other. So that's the required solution. Let us move on to the next question. The next question is, show that the pace of curves r is equals to a e power of theta and r e power of theta is equals to b intersect each other orthogonally. So let me take the first curve. R is equals to a e power of theta. So apply the log on both the sides. So we'll be getting log of r is equals to, it is log of a e power of theta. So if you apply the properties of logarithm, you will be getting log of a plus log of e power of theta. Or further I can write this as log A as it is plus. Now here this is log e power of theta can be written as theta log of e. But we know that the value of log e is 1. So I can write this as log of a plus theta because log e is taken as 1. So since we have got this expression, we'll try to differentiate this with respect to theta. Differentiate with respect to theta. Log of r differentiation will be 1 by r dr by d theta. Log a is a constant, its derivative will be 0. Differentiation of theta with respect to theta will be 1. So we get the value of 1 by r dr by d theta to be equals to cot of, for this first curve will take phi 1 is equals to, you have the value as 1. So can we express this 1 in terms of cot? So we know that cot of 45 will be 1. So therefore we have the value of phi 1 to be equals to pi by 4. So the first value phi 1 to be equals to pi by 4 is obtained. So let us move on to the second curve. R e power of theta is equals to b. So let us take log on both the sides. So log of r e power of theta is equals to log of b. So applying the properties of logarithm, we get log of r plus log of e power of theta is equals to log of b. Or further I can write this as log of r plus, again log e power of theta can be written as theta log of e is equals to log of b. Or further this can be written as log of r plus theta into log e value is 1, that will be equals to log of b. Let us try to differentiate this with respect to theta. So differentiate with respect to theta. Log r differentiation will be 1 by r into dr by d theta plus differentiation of theta with respect to theta will be 1, that is equals to log b is a constant, its derivative will be 0. So 1 by r dr by d theta can be written as cot of phi 2. So this plus 1 I will move it on the right hand side, it becomes minus of 1. So the value of cot of phi 2 will be equals to minus of 1. So I can write this value to be equals to, it is cot of, because it is a negative value, so cot is negative in the second quadrant. For minus 1 I can write that value to be equals to 3 pi by 4. So cot of 3 pi by 4 will be nothing but minus of 1. So how is that I have written this value as minus of 1? If plus 1 is cot of pi by 4, because it is positive value over here, it is in the first quadrant. For a negative value, it will be the second quadrant. So if you want to write in the second quadrant, you will be writing that as cot of pi by 2 plus theta values. In this case, this angle 1 will be nothing but your pi by 4. So the same pi by 4 what you have written over here. So you can write it over here. Because it is in the second quadrant, I am writing cot of pi by 2 plus theta. So theta value in this case is pi by 4. So if you try to simplify this one, this becomes cot of, you can take the LCM as 4. So if you take the LCM as 4, you will be getting this value to be equals to 2 pi plus pi. So that is nothing but cot of 3 pi by 4. So that is what I have got over here. The value of phi 2 will be equals to 3 pi by 4. Hence we got the second value phi 2 to be equals to 3 pi by 4. So therefore angle between the two curves will be nothing but modulus of phi 1 minus of phi 2. We just try to plug in the value of phi 1, which is pi by 4, minus the value of phi 2 will be 3 pi by 4. So this will be equals to, if you take the LCM and try to simplify this value, You'll be getting it is pi minus of 3 pi, which is nothing but modulus of minus 2 pi by 4. Or if you just try to cancel out, you're getting 2 1 times, 2 2 times. Therefore, you have got modulus of minus pi by 2. So because negative is under modulus, it becomes positive value pi by 2. So hence we have got 90 degree, which means that the curves are orthogonal to each other. Hence, the two curves are orthogonal to each other. So that's the required solution. Let us move on to the next question. The next question is, show that the pairs of curves r is equals to a into 1 plus sine theta and r is equals to a into 1 minus sine theta intersect each other orthogonally. So let us take the first curve. R is equals to a into 1 plus sine of theta. So let us take log on both the sides. So I'll be getting log of r is equals to log of a into 1 plus sine of theta. This can be written as log of a plus log of 1 plus sine of theta. Let us try to differentiate this with respect to theta. Differentiate with respect to theta. So log r differentiation will be 1 by r into dr by d theta. Log a is a constant, so derivative will be 0. Plus log differentiation over here will be 1 by 1 plus sine of theta into 1 plus sine theta differentiation will be cos of theta. So 1 by r dr by d theta can be written as cot of phi 1 is equals to, here we are left out with cos of theta divided by 1 plus sine of theta. Now since in the denominator we are having 1 plus sine theta, it's difficult to simplify that expression and write in terms of half angle formula. So therefore I'll keep this expression as it is and move on to the second curve. Simplification I'll do it later on. The second curve is r is equals to a into 1 minus sine of theta. So taking log, we'll be getting log of r is equals to log of a into 1 minus sine of theta. So applying property of logarithm, we get log of a plus log of 1 minus of sine theta. Let us try to differentiate with respect to theta. Differentiate with respect to theta. Log r differentiation will be 1 by r dr by d theta is equals to right hand side log a, the constant, its derivative will be 0, plus log of 1 minus sine theta, its derivative will be 1 by 1 minus sine of theta into inner differentiation, derivative of 1, constant will be 0, minus as it is, differentiation of sine theta will be cos of theta. So 1 by r dr by d theta can be written as cot of phi 2 is equals to, we are left out with minus cos theta divided by 1 minus sine of theta. So these are the two expressions we have got. Let me express both in terms of tan. So if I am taking the reciprocal on the left hand side, it is tan of phi 1. Because we know that tan of phi will be 1 by cot of phi. So I am taking the reciprocal over here on the left hand side. I have to take the reciprocal on the right hand side. So reciprocal will be 1 plus sine theta divided by cos of theta. So in the same way over here I can write the reciprocal will be tan of phi 2, and on the right hand side the reciprocal will be the minus sign as it is, will be getting 1 minus sine of theta divided by cos of theta. So let us try to simplify this one. I have given one relation, tan phi 1 into tan phi 2, its value will be minus of 1. This result I have given. So let us try to see whether we get that expression. If you get tan phi 1 into tan phi 2 to be equals to minus of 1, then we can say that the two curves are orthogonal to each other. So this is another relationship. So let us try to use it over here and check whether this condition will be satisfied. So I will be taking tan of phi 1 into tan of phi 2. So let's try to multiply this one. Tan phi 1 value is 1 plus sine of theta divided by cos of theta into tan phi 2 value is minus of 1 minus sine of theta divided by cos of theta. If you try to observe, this is in the form of 1 plus sine theta and 1 minus sine theta. It is a plus b into a minus b form. I can write a square minus b square. So 1 square minus of sine square. So 1 square is 1 minus sine square of theta whole divided by denominator cos theta into cos theta will be cos square of theta. And this negative sign that you have will remain as it is outside. So this will be equals to minus sine as it is. 1 minus sine square theta is nothing but cos square of theta whole divided by denominator you have cos square of theta. You can cancel out this cos square theta and cos square theta and you're left out with only minus of 1. So therefore we have got tan of phi 1 into tan of phi 2 is equals to minus of 1, which indicates that the two curves are orthogonal to each other. Hence, the two curves are orthogonal to each other. So that is the required solution. So that's all I have for today. Thank you.